or like signal refresh. You're already in. Refreshing. Okay. Showing the okay. Think. Let's wait for 2 minutes. But I'm not able to see. We'll minimize it like last time, or else we won't be able to see now. Hmm? We'll minimize it like last time. I don't know why it's not loading. Like the screen on the left. Okay, like this. Like, let me just see how. Like this, no? Mm. Yeah, yeah. No. It's fine, na? Yeah. Mm. Let's start then. Okay. Yeah. Yeah. Hi guys. Um, this is Mahesh.
And I'm Sansar.
Welcome back to our channel. And today we are diving into an exciting topic, that is vector databases and embedding search in current platform. Let me give you a brief about what's Kairan. Kairan is a powerful tool for building intelligent chatbots, and we can integrate advanced search techniques, and we can significantly enhance your bot capabilities. Uh, in today's session, we'll explore how vector databases work and the benefits of embedding search, and how to implement these features in our current platform to create more responsive and intuitive chatbots. Like, stay tuned to learn how to take your chatbot development to next level. From here on, Sensor will talk and explain a little bit about how we can um, use those mm, vector database and embedding search in our current bots.
Okay, so guys, here we've made like a basic bot. Basically, this bot consists of some FAQ questions. So what we thought is today we'll show you our latest feature that has been introduced in our platform. There's basically embedding search within our database action. So just to give you a bit of a context, what was going on at the back end was that there is a specific action that is known as DB action. So what database action is basically us filtering through our own database or our own vectors that we've made to get specific to fetch or to get specific text or specific information from the uploaded data. So let me just show you over here. We have, like, for example, this is how our action is on our platform, the database action. So we give it a name over here and we give it the FAQ table towards which it's pointed. So let me just duplicate this for you. Yeah. So what an FAQ table is it's basically it's you can think of it as an external RAG. Basically, it's an external document which we provide to our bot to get a bit of a context, because even though this is a chatbot and it's AI generative, but that does not necessarily mean so that we want it to generate any kind of information. We want it to give information within our own control, or like specific information which is very sensitive towards, like, our use cases. Like, suppose for this instance, if I'm a hotel chatbot, I would want to respond to the queries of the customers, with regards to what our rules and regulations are for that hotel. Like, suppose my check-in check-out time, how you can contact us, what our payment method is. So to answer, so this is a very, like, yeah, this is a very one of the use cases that I can just think of the top of my head. But of course, we can use this for more various use cases. Like, suppose if we were a shop and we wanted to filter out the data, then we would filter out the data, from food and then drinks or liquids, and then we would go to vegetables and such, so packaged foods and all. So what we do over here is, over here it's better if we provided an external database, and this external database is what's called an FAQ table. So let me just show you. For the people who were using our platform before, this used to be called as prompt management, but now we've updated it and it's not now called a knowledge vault. And over here we have the LLM content storage. So what this is basically, it's the as I said, it's an external RAG which we provide, or like a document which we provide. So what we can do is we can upload our information over here, and we can point this to do whatever specific queries we have. Like, suppose if I want to do database action, then what happens over here is that I can use database action to filter through my information that I've uploaded over here and get the specific answer. So what this does is it not only provides it with precise and accurate answers how I want to provide to the customer, but at the same time it's very fast, because all it has to do is it has to access the vector database and match the query and give me the response back. So let me just show you one way which we can do it. So over here, as you can see, this is an add FAQ table. So once I click on the add FAQ table, I can name my table something, like anything. Over here, suppose it's capitals, I'll name it capitals. And then there's two type of table content. One is content and one is payload. So content is basically for when I want it to be single lines, and I can feed it multiple rows. I don't want it to divide the data. So it can be just single line answers. Like, I'll just show you. Like, we have our default table over here. Over here, default table always has only content. So if I do add content, then I can add anything like I am, I am Sansar, and this is Mahesh. So we can click save over here. Okay, so we need to save 10 words. We will work and guide on his platform. So as you can see, we've saved the content over here, and this is the content which we want to provide the bot, so the bot can use these specific answers. Now these answers can be given in any kind of form. Like suppose we want to use it in prompt action, to so that the bot can respond by referring to this. So the bot can figure out that okay, so Sansar and Mahesh work in Nimble work, and their platform is Chiron, which they're currently working on. So the prompt respond can give the response back accordingly. Or if I use DB action, so for suppose in this case, what I can do is that I can add multiple columns. So it's like suppose over here this content, I may make this payload. So now what happens is, as you guys saw before, there was only rows of data that we could import. But now in this case, what we can do is we can make this a bit more accurate, because like suppose I don't always want to add my data and single lines. I want to make it a bit more refined, a bit more easier or uniform for me to find. So what I'll do is that I will add multiple rows over here, columns over here,
Columns.
sorry. And then I can give those columns name. Like suppose there's ID over here, like we can index it or give it numbers, so it will be easier for not only us for keeping track, but also for the bot to find. So what I'll do over here is we can give this ID. Next is the column type. If it contains text, integers, or floats, we keep it text for now. Enable search, and this is an important thing. Create embeddings. Basically, what's happening over here is that it will create embeddings for all the data that we store into this particular column. So suppose over here, if I type ID, and if I'm just giving here numbers like one serial numbers, or like employee numbers, like suppose Mahesh's employee number is 5600, so it does not make sense to create embeddings over there, right? Because there is no need for embeddings, as when we search, we won't search on the basis of that, we'll search for something more thorough. So suppose if this was a table for employee details, then what we have done is I would have given an employee ID over here. Then I would have given, and suppose employee uh, you know description.
And employee name.
Yeah, sure.
Name of that employee.
Yeah. So now over here, what we can do is we can have multiple things. Like suppose it would be important for us to have the employee description on, because if we search on the basis of that, it will create embeddings. And what happens is like it will be easier for them to search, because we know what the meaning or the value of each is. We'll go in depth more about what embedding search is, but for now, let's just get the gist of how we can on our platform have multiple columns, and within these columns we can name then specifically to not only give some context to the bot, but also to the people that are using the platform. So when we're fetching the data from this, or when we're using it for any database action, it will be much easier not only for us but also for them to recognize. So then over here there's nothing else. Like I can create a save over here, and okay, we no special, we have to use some cannot have them special characters over there. So we have saved the table over here, and as you guys can see, employee data has been made. Now every time I can add all three kinds of values. So now what I'll do is, like, after I add the values, then we can use this to search more search more accurately and more precisely, which is what we want. So this was one example. Now the example that I'm going to show you, what we're using it, is basically for this, for hotel FAQs. So what we have over here is we have a list of hotels, a list of 5 different kind of hotels. So this is suppose called Jungle Book. Then this is called Atharva Palace, and so on and so forth. So what we have done over there is, what we've done over here is that we have given like answers, okay, just answers to what we think the queries might be of customers that come on a hotel platforms, for suppose. So over here we're talking about weddings, we're talking about meeting rooms, we're talking about locations that we can visit nearby the hotel, the restaurants that the hotel has, and so on and so forth. So over here, what is going to happen is, once you are chatting to our bot and we attach an LLM to it, there can be two things that can happen. One, the prompt action directly fetches the results from the vector DB. This is done using similarity search. Okay. The second option now, what we have done is that in DB action, we could obviously search before from payload also, but now we can search from embedding search also. So what is going to happen is it is going to like simplify, not only like simplify, it is basically what it's going to do is it's going to filter out the query that we give, so it gives more accurate and best better results. So that is for payload, and embedding is attached to it. So now I'll just show you guys.
Like based on the search query that we are entering, it will filter that and will get and it will return return the
Results.
results like respective results based on our search query.
So I'll just show you this. So let's get back to our DB action now. So in our DB action, as you guys saw in our knowledge vault, we have the hotel FAQ as a FAQ table. So I've pointed this towards that, which means that I want to use this as my external source. So DB action is going to search on this particular FAQ table. Okay. And the next thing what I've done is I can add multiple of these. So there's one payload, like, and I can add another payload over here, and I can add one more payload over here. So after choosing this payload, what I do is I do a search. Like I can decide if I want to do a payload search or embedding search. So I'll just give you a bit of a context for what embedding search is and what payload search is. So to start for payload search, basically what payload search does is it filters through the data and matches the specific keywords that we've provided it. For instance, over here, our platform uses Quadrant for all the database actions and the searches. So what Quadrant does is like basically it's a data management tool which helps search and store the data at the same time. So it's better to use that because it handles all kind of data and it's trained on a lot of data also. So what this means is that if I do provide it any vectors, or if I provide any words, it can convert it into dense vectors because it has already been previously trained on a lot of data, and it can provide you all of the dense vectors of the word embeddings easily, and it will make more sense because suppose okay, so let me give you an example. So take for instance similarity search. So in similarity search, what it does is it tries to find or match the keywords that are same towards each other. So what that means is, suppose if Mahesh types "I am a good boy," and in our FAQ table over here, what has been mentioned is "I am not a good boy." Now, because Mahesh mentioned "I am a good boy," and it caught that the words similar to Mahesh's query is present over here, and it says that I am a good boy, I am not a good boy, even though both of them have different meanings, but that still does not mean that they have the same context, because in one place Mahesh is telling that he is a good boy, but it's written over there that he's not a good boy. So these don't match together because they do not have any context, in the sense like there's no explanation behind this. So this is where our embedding search actually comes into play. So what embedding search is, it's basically known as a semantic search or like a vector search. So this method or technique, it enhances the accuracy and relevance of the search by understanding the meaning and like the context behind the documents or the queries that it searches through. So like I said, because Quadrant is already a platform that has the capabilities to manage and store data, it has already been trained on these embeddings. So what happens is, when I go and store my data on there, it is much easier for it to catch the meaning behind the context that I'm trying to provide, because it can create those embeddings real quickly. So I'll just give you a bit of a context of how the embeddings work. So the first thing that takes place is like a text representation. So what happens is, like I said over here, as soon as I type or upload my data over here, like I've suppose over here I've done hotel, and over here I've done answer. So I've put two columns over here. As you guys can notice, I have my embeddings over here as create embeddings. That's I've searched clicked it as no, because I do not want any embeddings on this. But in answer column, when I have created embeddings, I've clicked yes. That's because I want to create embeddings for this, because when I'm going to be searching, my user will want to pick on the specific words or the semantics that I've been using over here, and I'll get my query answered respectively.
Like basically, the embedding is gonna create based on the answers, like the data present in the answer column. it will be created based on that data.
So now basically what's happening is that the text that I've uploaded over here, it gets converted into like dense vectors, or using embedding techniques such as word to vec, or sentence embeddings such as BERT. So these vectors, they capture like the semantic information about the text, like meaning like similar concepts are represented by similar vectors. So as you guys know, because machines cannot understand words, it's easier for it to convert into vectors or numbers, and display them as such. So it's easier and faster for searching also for the machine, but at the same time to fetch the results and display it also to us. So after that, what happens is the data that we've uploaded and gets turned into embeddings that are dense vectors. They get dumped into a vector space, and both the search queries and documents are represented in the same vector space. So like I said, when Mahesh had typed "I am a good boy," that gets converted into vector dense dense vectors. At the same time, what I had uploaded over here saying "I am not a good boy," that also gets updated into dense vectors. Now what happens is this allows for like a comparison between the query vector with the document vector. So then the semantic similarity comes into play. Now, because these are embeddings, it's much more better understanding to capture semantics. That means the meaning behind the context. So it just won't match "I am a boy," "I am a boy" from it. It will also notice the "I am not a good boy" part of it, and understand that okay, he is not a good boy, but he is a good boy. So that is the main differentiating factor what we're trying to talk to you about, which is way better from embedding point of view than versus a similarity search. So next, what happens is after the embeddings have been created and the dense vectors have been put into the vector space, we do like a similarity measurement to find the most relevant documents, or give a query similarly to basically find out how close the similarity is. Now this can be done through two methods or more, but like just to give you a context, one of them is cosine similarity, and the other one is Euclidean distance. So in cosine similarity, what happens is, suppose we took Mahesh's query as a vector, and my query was also there as a vector. So these two normally would be placed very close to each other because they make sense semantically, and also they are very similar in words. So now we'll check how small the angle is, just to put it in layman terms. For cosine similarity, we'll check how small the angle is from my vector, or from the document vector to Mahesh's query vector. And if it is, we found it to be very small, that means it's a perfect match because, we found out that it's similar, the vectors are very similar to each other, and we will fetch those queries because it's the closest to what Mahesh's query was. So that is
That
how.
means it's a relevant result for our search query.
So basically then what happens is like the results are ranked, and based on the similarity scores, we can we get more relevant and contextually accurate results as compared to a traditional keywords or similarity search. So, like, if I wanted to give you an example, suppose like a user searches for a particular sentence, like "how to bake a cake." So, what happens in this is that in a traditional like keyword-based system, it might return the words that the user has typed. It will contain all the words as a document, like "how to bake a cake," 5 words. Okay, so what it has just taken out the words exactly as it is. It's not found any meaning behind it. But in an embedding search system, it understands that the user's intent and can return a document that provides that provide cake baking instructions. Even if they use different words like cake recipes or steps to bake a cake, it will understand that all of these fall under the same umbrella or the same category, and the vector dense vectors will be created around these, which will be very similar to each other. So now what we'll do is, now we'll show them the platform and how the DB action is working in this sense. So over here,
Let's go to conversation. Sorry.
yeah, let's show them first what the JSON is. So when we're sending a payload search, we are sending them a particular JSON. Just go to the other tab ones. Yeah. So as you guys can see over here, we've in our payload feature, we are searching with a JSON. So in this JSON, what we've mentioned is that there's a filter, and in filter we have must. So these are all the keywords that Quadrant has in its own JSON format. So over here, what we want is it must match. Basically, match in the sense we want it to match with the column hotel. As I showed you guys, we have a column over here named hotel, and over here we have within the hotel columns all of these names. So in this, from this point of view, we want the text to match Atharva Palace. So the column hotel will have Atharva Palace over here, and we wanted to fetch all the queries that Atharva Palace has. So what happens in this case is that it will narrow down the document that it will have to search, so that will be much quicker also for a return. So now, if you guys are, in case you guys are wondering how we can fill, every time we can fill this. So we've actually, what we've done over here is we've used the value, but what we can do is we can change this to a slot or the user message also. So in case we change it to slot, what's going to happen is we're going to have the location saved. Location saved as in we can have the user select before itself what kind of queries they're going to search about. So suppose if they wanted queries about the Jungle Book, we can save it in a slot, as I'm sure you guys would know from the previous videos, how we can make it, through fonts or through drop downs or through our own rasa form also. So that's how we can save it to slots, and then we can continue so on and so forth. So for now, we're saving it in value because we want to show you guys what is the workaround behind it, what's going on in the back end. So that is basically it. We're trying to match the column that is called hotel with what is filled in the column that is called Atharva Palace. Limit is basically how many search results we wanted to return back. We've put it as 30 because the smaller it is, the quicker we get. So what's going to happen is it's going to return us all the payload of the 30 queries, and on top of the 30 queries, we're going to do a embedding search. Okay, so that is what the goal is. So now over here, we've put embedding search too. So there's two things that gonna happen. That's gonna happen here. First, the DB action will take place, and it's going to filter all the data going through the column hotel and the mentioned hotel name that we have over here. So it will filter that, give us at max 30 results, and on top of that, we will have an embedding search which will be user message, because we wanted to specify in terms of what we are only searching for. So let's do one thing. Let's directly jump into it, and we'll take it for a test. So I'll just open the conversations page. So we have stories and intents over here, as you guys know. So right now we have this in our NLU fallback story. So what we will do is we will open the DB action, and let's give this a try first. Okay. So I will type. Suppose I will type something like wedding. Okay, so the DB action has returned us certain things. Mahesh, can you just have a look?
Yeah. Yeah, we search for the word waiting, right? First, it will what it will do is first it will fetch the results based on that payload search, and after that it will apply that embeddings on top of that. And here are the results that we get after completing both of that queries.
So over here, what it does is it provides us the top 30 search results that it thinks is the best matched. So over here, it tells us also like the score that we get, or how good the match is. So we had done a basic query like wedding. We can get we can get more. So as you guys can see over here on top, let's just see what we had uploaded. The particular query that we had uploaded over here. As you guys can see over here, written, yes, we host destination weddings in our so and so hotels and our properties, and we offer delicious food, wedding planning, and facilities For more details, you can contact. So because wedding is already there, I think it makes it easier for it. So let's try and take it, make it a bit step harder. I'll type like, can I get married here? Now you can see in this, I've not used any words related to what was there in the answer. So now what we're doing is we're still going to expect similar results because, yeah. So as you guys can see, my query over here was, can I get married here? And one of its first results back was, yes, we can host destination weddings. So as you guys can see, embedding search works really well over here because it understood that my query is related to weddings, and it found out the dense vectors and tried to match it with this specific document or this specific query. And what we're getting is the best results possible from the similarity score, or the the best performing match over here. So we can try out multiple questions over here, like do you have um, a conference room? So in this case, you can see, yes, Club Florence, we have 4 meeting rooms. So it understood that I'm talking about, a corporate event and an offsite, and it found out that best possible result for my specific query. So all of these queries are working on two things. First, it's taking out the filter that we've given. In this case, it is Atharva Palace. And out of those 30 queries, it's filtering from my user message, which I have given it over here. So this is the user message. So just to show you how the backend is, working, we have our DB action over here. In our DB action, we are sending it the payload that is, the hotel column name and the Atharva matching. So the payload search works, it's matching with that. Then we're doing embedding search that is from the user message, basically the query that we're typing. And on the basis of that, it is going to refer to the FAQ table and give us these results that are matching to it. So this was our basic explanation of the DB action and our new latest feature, which is the embedding search. Just before we end this live stream, I want to show you guys one more thing. What we can do is we can club the database action along with the prompt action. So now what is happening is, we're getting all the results from the database action, but this is not how we want to present it to customers, or we'd rather like it to be presented in a much better format. So now what we're going to do is, I've already made this prompt action. You guys, I'm sure, must have seen our previous videos and figured out how to make a prompt action. So I'll just dispatch the response. I'll turn this response off because we don't want to get confused with what is coming. So now what I've done is, I have saved my DB action into a particular slot. This slot is called rating. So what I've done is, because I've saved this into a slot, it's going to give me the best performing results that I've got, that it has fetched, and it's going to all put it in the slot. Now what I'm doing in prompt action, I'm going to provide the slot to the bot, and I've told it that use the top answers from the data provided to you, so you can answer the user query accordingly.
In order to if you wanted to get a better understanding of this prompt action, just refer to the previous videos in the same channel that we have uploaded. Yeah.
Go ahead. I have got the prompt.
Yeah.
So basically over here in system context, I've given it a basic, very basic prompt. I've told it that you are a hotel chatbot, answer the queries to the user accordingly and use the data provided to you in the slot. Add emojis and make sure the user will be satisfied with the answer. A very basic query, and all I've done is provided the slot. As you guys can see, to provide it the slot that has been saved, we go to the context type, the source, we select slot and slot the rating. So this is going to chain it. It's going to change the prompt action to the DB action. So now let's give this a try. Now over here, I'll try, am I allowed to bring dogs? So okay, you guys can see over here, we've got a very nice response as compared to before, right? Because before we were just getting results, but now this is the answer straight from our prompt action. and it has said, we're very sorry, but we're unable to accommodate pets at our properties right now. We understand the pets are cherished member, and so on and so forth. So as you guys can see over here, I got the query really quickly. Why? Because from DB action, I was able to perform payload searching, embedding searching at the same time. And in this case, what I've done is I've made the answer better, or I've polished the answer by adding a prompt action. So, I'm using an LLM for LLM to figure out, acha, that this is a proper answer to the user query. And at the same time, I can, give it in a much more polished and thorough detail that it is a customer. So you're going to be a hotel chatbot, and you're going to give it an answer like this. So it has an emotion context also, like we're sorry, it's apologizing because pets are not allowed. But at the same time, it's using emojis also to talk to the customer in a specific tone, as we want them to be satisfied. So yeah, this is it, guys, for today's YouTube video. We hope you guys learned a lot about the Chiron platform and about our latest embedding search.
Yeah. Mm. Like we just build a simple bot to just let you know about this DB action only. Like if you want to explore more, like something like complex stories and flows and all, you can refer to the previous videos. There are actually around 10 to 12 videos are there. You can refer those. You can get a better understanding of how to build the bots. Actually,
Yeah,
this
so you guys can follow us on our Discord channel. We also have Facebook, or YouTube, obviously, from where you guys are watching, and also LinkedIn. So make sure to catch up on our latest releases, and we'll be pushing out more features. So it'll be better for you guys also to enjoy our platform at the same time. So yeah, thank you all.
Thank you all. Bye.